Joshi. Our today's topic for this particular video session is radioactivity and types of radiations. So what do you understand by the word which is known as radioactivity? Now in general, radioactivity is a property which is shown by atomic nucleus, right? So there are actually 2 or 3 different types of properties. Some of the properties are shown by atomic nucleus, some of the properties are shown by atomic orbitals. But this particular property is known as a nuclear property. So this is a typically nucleus property. Generally, atomic nucleus contains protons and neutrons. When the change in protons and neutron occurs, at that time the particular radiation will be there or disintegration of that nucleus occurs. So it will either release a huge amount of energy in the form of particle, in the form of radiation, etc. So that particular phenomenon will be counted as radioactivity. And depending upon the nucleus, depending upon the type of nucleus, depending upon the number of protons, number of neutrons, etc., which is present inside the nucleus, we will have here different types of radiations, right? So it is not necessary that each and every atomic nucleus actually releases the same number of radiations. It will show you different types of radioactivity behavior. It will show you different types of emission of that particular rays. Okay, so a number of elements such as uranium and radium are unstable. So their atomic nucleus are unstable actually. Now, their atomic nucleus breaks off its own accord to form a smaller atomic nucleus of another element. And the protons and the neutrons in the unstable nucleus regroup to give the new nucleus. Okay, understood it here very clearly that the unstable atom's nucleus breaks down on its own accord. It's its own characteristic. It doesn't require any other out source, or it doesn't require any other factor, outer factor that is not required to break down. Okay, understood it very clearly everyone. Okay, so their atomic nucleus breaks down and it will form a smaller atomic nucleus which is a stable one. So it will convert itself from unstable one to the stable one. Now the proton and neutrons in the unstable nucleus regroup themselves to give the new nucleus. Okay. So this causes the release of excess particles and energy from the small, or from the actually energy from the original nucleus, which we call radiation, right? So they will release themselves, and that particular release is known as radiation. Now, the elements whose atomic nucleus emits the radiation are said to be radioactive. And the spontaneous breaking down of the unstable atoms is termed radioactive disintegration or radioactive decay, right? We will have here 4 different terms. Number 1, radiation. Number 2, radioactive. Number 3, radioactive disintegration. And number 4, radioactive decay. Okay, so these are the 4 terms which we need to understand that how the radioactivity works and what is the actual meaning of radioactivity. Right? So the disintegration or decay of unstable atoms accompanied by emission of radiation is called radioactivity. Fine? So that particular decay of unstable atoms, what will happen? The unstable atoms removes the excess protons and excess neutrons. That excess protons and neutrons, they bulk up with each other, and that basically that is the disintegration of the nucleus. So that disintegration will be taken, or it will take the form of emission of radiation, and that emission of radiation is known as radioactivity. Okay everyone? So that is known as radioactivity. Fine? Now let's move ahead that what are the types of radiations. So the radioactive radiations are of three types. These were sorted out by Rutherford in 1902 by passing them between two oppositely charged plates. So what Rutherford does was he passed this type of radiations in between the two oppositely charged plates. So the one bending towards the negative plate carried positive charge and were named alpha rays. Now the one or those bending towards the positive plate carries negative charge, which is known as beta rays or beta radiation. So one is alpha radiation, one is beta radiation. Now the third type of radiation, being uncharged, passed straight through the electric field, were named gamma rays. So here we will have three different types of radiations. Number one alpha, number two beta, number three gamma. Okay. So alpha rays actually are positively charged radiations. Beta rays are negatively charged radiations. And gamma rays are the neutral charges or the neutral rays. Right? As you can see in the image, we have put a radioactive material at the first position. So that particular radioactive material releases the radiations, that is alpha, beta and gamma. Now that particular radiation will be passed through two oppositely charged plates. The upper one contains negative charge, the lower one contains positive charge. You can see it in the image also, right? So what will happen here? One will get attracted towards the negatively charged plate. So we can understand that the positively charged will be attracted towards the negative plate, right? So that is termed as alpha rays. Second one, which will become attracted towards positively charged plate. So it will contain a negative charge on itself. So it will be known as beta radiation or beta rays. Now the third wave, which is neutral in nature, it will go directly to the zinc sulfide screen, is known as gamma rays. So Rutherford does this experiment and proves that there are actually three different types of radiations present. Okay. Now let's move ahead to the properties of radiations. So we will have here alpha, beta and gamma rays, right? So alpha rays, beta rays and gamma rays, they three differ from each other in nature and in properties. So there are chief properties which we will take into account is number one, velocity, number two, penetrating power, and number three, ionization. So let's move ahead to the alpha rays. The first type of rays is alpha rays. So alpha rays are symbolized as 2 alpha 4 or 2 Ag4. If we talk about the nature, then they consist of streams of alpha particles. By measurement of their E by M, Rutherford showed that they have a mass of 4 AMU and charge of +2, and they are helium nuclei and may be represented as 2He4. If we talk about the velocity, then alpha particles are ejected from radioactive nuclei with very high velocity, about 1/10 of that the light. Our next one is penetrating power. So because of their charge and relatively large size, alpha particles have very little power of penetration through the matter, and they are stopped by a sheet of paper or 0.01 millimeter thick aluminum foil or a few centimeters of air. Last one will be ionization. They cause intense ionization of a gas through which they pass, and on account of their high velocity and attraction for electrons, alpha particles break away electrons from gas molecules and convert them into positively charged ions. Right? Our next one is beta rays. So if we talk about nature of the beta rays, they are streams of beta particles emitted by the nucleus. From their deflection, electric and magnetic fields, Becquerel showed that beta particles are identical with electrons, and they have very small mass, that is almost 1/1827 AMU and charge of -1. So beta particle can be symbolized as -1 beta E0 or -1 E0. Now let's talk about velocity. So they travel about 10 times faster than alpha particles, and their velocity is about the same as of light. Let's move ahead to the next property, which is penetrating power. So beta particles are 100 times more penetrating in comparison to alpha particles. This is so because they have higher velocity and negligible mass. Beta particles can be stopped by 1 centimeter thick sheet of aluminum or 1 meter of air. Our next property is ionization. So the ionization produced by beta particles in a gas is about 1/100th of that of alpha particles. Though the velocity of beta particles is higher, but the mass being smaller, their kinetic energy is much less than alpha particles, and hence they are poor ionizers. Let's talk about the next one, which is gamma rays. So unlike alpha and beta rays, they do not consist of particles of matter. So gamma rays are a form of electromagnetic radiation of shorter wavelength than X-rays. They could be thought of as high energy photons released by the nucleus during alpha and beta emissions. They have no mass or charge and may be symbolized as gamma. If we talk about velocity, so like all forms of electromagnetic radiation, gamma rays travels with the velocity of light. Our next property is ionizing power. So their ionizing power is very weak in comparison to alpha and beta particles. And a gamma photon, or basically gamma rays, displaces an electron of the gas molecule to yield a positive ion. Since the chances of photon-electron collisions are small, gamma rays are basically weak ionizers. Because of their high velocity and non-material nature, gamma rays are more penetrating and they cannot be stopped by a 5 meter or 5 centimeter thick sheet of lead and several meters thick of concrete. Now here in the image, as you can see, alpha rays, which contains 2 positive charge, can be stopped by paper. Beta rays, which contain 1 negative charge, can be stopped by 1 centimeter thick aluminium. And third one is gamma rays, which cannot be stopped even by 5 centimeter thick lead block. So in that manner, as you can see, this shows the penetration power of all the 3 radiations. So alpha rays are least penetrating, beta rays are medium penetrating, while gamma rays are highly penetrating in their nature. This is all for this session. Thank you so much.